Today, we're going to talk about a library called Effect. And honestly, it's a real game changer for how a lot of people are starting to write TypeScript and JavaScript. The whole idea is to make your code safer, way more predictable, and just easier to manage. So let's jump right in and see what all the fuss is about.
You know, we've all been there. You write a function, you look at its type signature, and you think, okay, I know exactly what this does. But sometimes that code is lying to you. It's hiding a secret, and that secret can bring your whole application crashing down.
So I want you to ask yourself this. When you look at your own code, does the type signature really tell the whole story? Or are there these hidden dangers, these potential crashes, just lurking beneath the surface, waiting to pop up when you least expect it?
I mean, take a look at this super classic example. The type signature here promises us that if you give it two numbers, you'll get a number back. Simple enough, right? But we all know the catch. If that second number, b, happens to be 0, bam, the function doesn't return a number at all. It just throws an error and crashes. The type signature lied. It made a promise it couldn't always keep. And that's the fundamental problem that Effect is designed to solve.
And this is where Effect really flips the script. Instead of just running your code immediately, Effect lets you describe the work you want to do first. It's a huge mental shift, really. We're moving from just doing things to first creating a declarative blueprint of what needs to be done.
So, what is an effect, really? Well, think of it like a recipe for a cake. The recipe itself isn't the cake, right? It's just the detailed set of instructions for how to make the cake. An effect is exactly that, a blueprint. It describes a job to be done, but it hasn't run yet. And because it hasn't run, we get this incredible amount of control over when and how it actually executes.
Okay, so at the heart of all this is the effect type, and it has these three generic parameters. Let's break them down. First, you've got A, which stands for the success value. That's the type of thing you get back when everything goes right. Then you've got E for error, which tells you the exact type of error that might happen. And finally, R for requirements. These are the services or contexts the effect needs to run. Suddenly, all those hidden behaviors, they're not hidden anymore. They're right there, plain as day, in the type signature.
So, how do we start building these blueprints? Well, it all starts with two really simple ideas. One for when things go right, and one for when they inevitably go wrong. To build a computation that you know for a fact is going to succeed, you use effect.succeed. Now look at that type signature. It produces a number, that's our success value, but the error type, it's never. And this is where things get really cool. Never is TypeScript's way of making a rock-solid promise, saying this outcome is literally impossible. The compiler can now prove that this specific effect will never fail.
And on the flip side, of course, we've got effect fail, which lets us be explicit about failure. In this case, you'll see the success type is never, which guarantees this effect can't possibly produce a successful value. This is the magic right here. We've just taken something chaotic and unpredictable, a runtime bomb, and turned it into a predictable type-safe value that our program knows exactly how to handle. No more surprises.
Okay, let's go back to our old friend, the divide function. The difference is just night and day. Before, the signature was a lie, but now the new signature, effect, number, error, tells the absolute unvarnished truth. It says, hey, this computation is either going to succeed with a number or it's going to fail with an error. No more lies. No more hidden landmines.
All right, I know what you might be thinking. This is cool for a simple divide function. But what about the real world? You know, the messy stuff. Side effects, API calls, all those legacy patterns we have to deal with every day.
Well, Effect gives us a unified way to handle, well, everything. For your synchronous code, if you've got a side effect that you trust won't throw an error, like a simple console.log, you wrap it in Effect sync. But for the risky stuff, the code that might just blow up, like JSON.parse, that's what Effect try is for. It acts like a safety net, catching any potential exception and neatly placing it into the Effect's error channel.
And you know what? The exact same logic applies to your async code. A regular old promise has the same exact flaw we talked about. Its type signature hides the fact that it could reject. Effect fixes this with effect.promise for promises you know are safe, and effect.tryPromise for the ones that might fail, like a network request. It safely catches that rejection and makes it just another predictable, type-safe outcome.
And what about those, let's say, ancient callback-based APIs that we all still have to deal with sometimes? Yep, Effect has a solution for those too, with effect.async. The process is actually super simple. You call the old API, and inside its callback, you use this special resume function to tell Effect whether things went well with effect.succeed or if they went badly with effect.fail. It's a perfect bridge from the oldest async patterns into this modern, unified model.
But this is where it gets really powerful.
Effect.async isn't just about handling errors. It can also return a cleanup effect. So what does that mean? Well, think about it. A user clicks away from a page while a file is uploading. If your operation gets interrupted, Effect will automatically run your cleanup logic for you, like closing that file or aborting the network connection. That's incredibly robust resource management just built right into the system.
Okay, so let's step back for a second. When you add all of this up, what's the big payoff? What does it actually mean for you as a developer day to day? Well, it means you get to write code with a whole new kind of confidence.
So let's recap the big wins here. First, your errors become predictable values that the compiler actually understands and checks for you. Second, those hidden exceptions and unhandled promise rejections, they're basically a thing of the past. Third, you get this one single unified way to handle everything. Sync, async, callbacks, it doesn't matter. It all comes together to make your code more predictable, easier to compose, and frankly, just a heck of a lot easier to reason about.
So I'll leave you with this one last question. Just imagine, for a moment, if every single operation in your application, from reading a file to fetching data from an API, was this honest, this explicit about every possible thing that could happen. What kind of amazing, rock-solid, ambitious software could you build if you never had to second-guess what your code was really going to do?